Hello everybody, welcome to the session. Now I am going to introduce you, a new service called Namos to the OpenStack community. Namos is formed from the word OpenStack manager. It is a jumbled word of like the man and OS. So the word is formed as Namos. Okay, so everyone of us, we know that like OpenStack is a distributed cloud operating system, and which helps to set up the public or the private cloud in a heterogeneous data center. For operator, it provides configurable device driver plugins, which helps to consume the required hardware devices or software defined devices. And for the consumers, it gives you the REST API, CLI, and of course origin plugin, panel. So that the consumer can manage their resources such as like storage, volume, instance, etc. Okay, I see the OpenStack ecosystem like this. Okay, there is a 4 parts involved. First is the OpenStack community code, that's completely free from the community, and there is a installer. Either it can be an open source installer or the commercial installer, and OpenStack is meant for the cloud setup. So always you will have a data center. So if you go to any data centers, there will be data center management software, and 4th part is the real hardware or the software defined devices. Okay, so OpenStack gives the platform, and installer gives you the automation of the installation and the configuration part. Certainly, it helps to onboard the devices. Okay, it does not support all the devices supported in the OpenStack, but it gives the limited support. The data center management software. Okay, so one way you are consuming the devices from the data center in the OpenStack, and the other side, the data center management software helps you to manage them. So in other words, the data center management software will be handled by the data center admin, and the installers and the OpenStack will be handled by the cloud admin, and the data center is a binding bot in between them. Okay, what is the problem in this ecosystem? Okay, so as a community, we give so much of support to the different heterogeneous devices. Okay, but if you are taking any installer, whether it is a community based installer or a commercial installer, it has certain limitation. First, it does not support all the devices supported by the OpenStack. Second, it has to maintain the configuration, because OpenStack is completely fine tunable by the configuration. So obviously installer has to manage it, maintain it. So maintaining that configurations for every release of the OpenStack is a cumbersome. For example, today device driver has say 5 configuration, and say in the Newton we are introducing a new configuration, 6th one. If you are going to use the installer, you have to wait till the installer enable that 6th configuration parameter, though OpenStack already support it. And for the data center management software, okay, it does a lot on the management of the data center. It does day-to-day business operations. Say during the maintenance cycle, say you want to bring the consumption of the device in the OpenStack. Today it is not possible. We have to do some means. There is no way the OpenStack gives any service by which we can go and put the devices in the maintenance state. And data center. Okay, so if you take any hypervisor or the storage device, it is like a one-to-one bounding today. What I mean is, one Nova compute can handle only one hypervisor. Say you have a high-end hypervisor, you want to put 2 Nova compute on top of that in order to meet that high-end configuration. It is not possible today, because there is a double counting comes up. Apart from all of this, OpenStack community itself lacks with some feature. Okay, because there is no service exists to represent the device in the OpenStack. Okay, say I want to say for my tenant, I want always get the instance or the volume from the given set of devices. So say like your data center has 100 hypervisor, I want to get the VM from only given 10 hypervisors. For some security reason, that is not possible today. And say you want to maintain the quota management based on the device, it is not possible. Similarly, if you want to do the reservation, it is not possible. And there is no device onboarding exists in the OpenStack community code. Usually it is given by the installer, but installer does not give support for all the devices, it always limits. And on top of all of this, once you deploy your OpenStack, next operator what he want is he want to see how it's got deployed, he want to verify the deployment whether it is up to his expectation, I mean up to the design, but there is no tool or service available today in the community. So these are the major problem in the ecosystem. So how to solve it? Okay, when we look at all of these things, it all bound to the place where there is no service exists today in the OpenStack to represent the device. Okay, for instance, you can go to the Nova and say I can power on, power off, create, do whatever we want. Similarly, volume, you can go to the cinder. Similarly, if you want to manage the device, say I want to onboard your device or I want to put the device to the maintenance state, there is no service exists in the OpenStack. So to solve this, so model the complete OpenStack deployment and whatever the device it's consumed as a programmable entities. That means you can operate them over the REST API. Okay, something like this. Okay, so the green color it has a service like a node. It can be a controller node, compute node like that. So on the node you will deploy the service. Service is nothing but the made of service component. So if you take any service component, it have its own associated configuration, service configuration, and every component will be loaded with set of device drivers. Again, device driver will have a set of configuration to it. And any device driver if you take, it will have a direct supported devices. Okay. Now the device is model. Okay. Once you model the device, you want to connect to the device. Say for example, if you want to connect to the chef, so give the IP address, username, password. That's the endpoint. And every device consumed in the OpenStack has the capabilities. So that you can model as a device capability. Okay. By doing all this thing, I mean by modeling all these entities as a one service, we can solve all the problem what I have seen in the earlier slide. So you can add, update, delete the device, onboarding, or say if you want to put the device into maintenance state, you can do. Okay, you can maintain the device capability. How it helps? It is going to help you to maintain the quota management or the reservation. Okay, so I onboard the device into the OpenStack. Now I want to attach the device to either 1 or 2 Nova compute. I can easily attach them. Like how you attach the volume to your instance, similarly you can attach the device to a given service backend. For example, you can attach the say vCenter to the Nova compute, and you can enable or disable API itself, or you can disable the service component. And on top of all of these things, you can fine tune the configuration. As the end operator, sometimes he want to fine tune the configuration, sometimes he want to do the zero configuration. Okay, both of the things we can achieve by using this. Anyway, the community is the one, I mean OpenStack community is the one, it gives the complete set of configuration. Okay. So on top of this, once this model in place, it helps you do the 360-degree view of the deployment. What it means, okay, I deploy my service, I want to know where all my components got deployed. Say take the Nova, I know like I want to know where the Nova API is deployed. I want to know where the Nova compute is deployed, which node it has deployed. Similarly, if I want to look at from the device, I want to know which are the components consuming me in the OpenStack deployment. So that is from the device point of view. From the node point of view, I want to know, okay, on the given node, what are the service components got installed, what are the services running. So the complete picture of the deployment, it will bring in front of you. So you can see the see this 3 perspective from either the node or the service or the device. On top of this, if you have multiple regions, you can see this view from the region itself. Say you have like 10 regions deployed with the OpenStack. So per region, you can view this. Okay. So these are the features. So I bifurcate them into 4 major features. Okay. First one is the auto discoverer. So it gives a 360-degree view. Okay. Once you get the deployment view, you can apply a compliance check. Say it meets my policy password, or it meets my say security policy. All those things you can bring on top of that. Second, okay, as I mentioned earlier, every OpenStack component is highly configurable. Okay, so from one service, you can do configuration across the deployment. Okay. Say your device is consumed across the 10 Nova compute deployed in 10 compute nodes. From one place, one service, you can do the configuration. Similarly, you can do this for like a messaging queue or the DB, because it is getting scattered across almost all the nodes got where the OpenStack is deployed. So, from one place you can fine tune it. Okay. Like in a traditional operating system, it gives you the we can bring easily the device manager. It's like a shared wall between the cloud data center and the OpenStack. As I mentioned earlier, it will help you like data center admin to onboard the device, and OpenStack admin or the cloud admin to consuming it however he want. Similarly, it will give you a service manager like in the Windows operating system, where you can start and stop the any given service altogether. Okay. To access all these features, so Namos provides the CLI, API and the Horizon panel. So, let us see like some example use cases. Okay. So, for the operator, I can onboard the device. Okay. Also, if you want to fine tune a configuration, I can do. As an admin, cloud admin, I can manage the quota or the reservation, and as a developer, mainly I can bring any features which is depend on the device, because Namos gives the representation for the device. Okay, so currently I implemented this the first feature ODAT, and I kept in the OpenStack GitHub. So, and I am implementing the next one, configuration as a service. Okay. So, now Namos is in place, and what are the problem we have seen earlier in this 4 quadrant, Namos gives a solution for it. Okay. If you go to the community, I can develop any feature based on the device, or if I want to fine tune or a zero configuration, I can do that. We have seen like we can see the 360-degree view of the deployment. Also, we can bring the compliance check. If I go to the installer no more need to bother about the configuration schema maintenance. Okay. Installer can directly leverage the Namos for the configuration management part. And if you go to the data center management software, okay, as part of the day-to-day maintenance activity, it can just invoke the REST API to the Namos, say, okay, just bring those device to the maintenance state. So, as part of the business flow, you can integrate it. Okay. So, for the data center devices, you can say for example, given device, you can bring more than one Nova compute or the cinder volume, etc. So, it is all about the Namos. So, I kept this I checked in the code in this OpenStack Git repository, and I have created the wiki, the given wiki for Namos more detail. Okay. So, Namos just binds the OpenStack deployment and its ecosystem in a programmatic way. Okay. What it helps? So, it for the operator, it helps to fine tune the device and service controller also onboard or for the devices, and for the developer, it helps you to develop any feature based on the device. Okay. Just let us see, I have 2 more minutes, so I can give the perspective from the installer in detail. Okay. So, if you look at the day-to-day life on the OpenStack deployment, so first we will set up all the nodes like controller node, compute node, etc. Then we will make the data center ready for the consumption. Okay. This is from the cloud data center point of view. Okay. So, the complete OpenStack code is living in the GitHub repository, and OpenStack gives the configuration guide. Okay. All the distros, what they do, they take the code from the GitHub, pack it. The packing is nothing but the service component and the installer device drivers, and they read the configuration guide and then convert it into like playbooks, configuration playbook. On top of that, they provide some installers for the device, software defined device or some like a Chef, etc. So, all these things they call it as installer or the distro. So, it is a packaging part. So, when you are deploying, all the component will go to the respective node, okay, and the device will go to the data center side. Say for example, This, for example, the VMware thing, once you install, you can configure it to the compute. Similarly, you can do this for other things. Okay. What Namos is going to help for the installer, whatever is highlighted here, like you don't need to bother about any configuration schema management. Okay. Installer can leverage the Namos to do that part. So, that way installer also getting advantage as well as the end customer also getting. They no need to wait till the installer to enable any updated configurations. That is all about Namos. Thank you for the session.